Okay, in this lesson, we're going to be talking about the second most famous irrational number in all of mathematics. And everybody knows about pi, but this second irrational number, not a lot of people know about it unless they've dealt with higher mathematics, and it is the number e. E is also, once again, an irrational number, just like pi. It's irrational. And again, the reason it's irrational because it's a crazy number that has no pattern, doesn't repeat, just like pi, has an approximate value of 2.71828 dot. Just like pi is 3.14159, there's the approximate value of e, and it does continue on and on forever. E often occurs as the base of exponential and logarithmic functions. That describes real-world scenarios, especially when you're dealing with some sort of exponential growth, whether it be the way that our population is growing, whether it be any kind of growth of that form, or even when we're dealing about growth in a bank account, the way that our money grows when we're placing it in a bank account, E gets involved in a lot of these situations. Exponential functions with a base of e are called natural base exponential functions, a natural base. An example of this, f of x is equal to e to the x power, and it's so famous and so useful that we actually have calculator buttons dedicated to e to a power. Base e logarithms. Logarithm functions with a base of e is called a natural logarithm. Example, f of x is equal to the log base e of x. However, this is often abbreviated as f of x is equal to the ln. Anytime you have a log of base e, the natural logarithm, we call it the ln of x. And if there's no number down there, it's understood to be an e is the base. So converting between forms, let's same thing we did before. Let's write each of these in a logarithmic form. So this would be log base e of 24 is equal to x, or we can just write that as ln of 24 is equal to x. And again, we have that ln button on our calculator. This would be log base e of x is equal to 9, or just the natural log of x is equal to 9. This is log base e of 72 equals x plus 5 in logarithmic form, or the ln of 72 equals x plus 5. Next up, let's change each of these to an exponential form. If it's an ln, again, you can put an e down there. This is e raised to the 58th power is equal to x. This one is e raised to the x power is equal to 6. Or here, e, which is the base, raised to the 32 power equals x minus 9 to change forms. The same rules of logarithms apply to natural logs as it did to regular logs. To add two logarithms together, we take the 3 and the 16 and we multiply them. So this would be the natural log of 48. This will give us some extra practice. Anytime you have a 2 out front, it can be moved up to an exponent. So this is the natural log of 63 minus the natural log of 9. Anytime you have the subtraction of two logs, we can combine those with division. This would be 63 over 9, which we can just write as ln of 7. Next one, move the 1/3 up to an exponent, and let's move the 2 up to an exponent. First off, 64 to the 1/3 power is the cube root of 64, which is 4, plus natural log of x squared. Now we have two natural logs being added, so we can combine those by using multiplication. That would be 4x squared. Now let's do right the opposite. Let's expand these. The natural log of 5x is the natural log of 5 plus the natural log of x. Multiplication is expanded with addition. This one, we can actually raise the stuff inside to a power first. That'd be a to the 6th over b to the 2nd, which would be the natural log of a to the 6th minus the natural log of b to the 2nd. Anytime you have division, you can split it using subtraction. And the last one, we can do this, clean it up a little bit first. This would be the natural log of m squared n raised to the 1/3 power, which we could write as the natural log of m to the 2/3 power and n to the 1/3 power. Now we can split it using addition. This will be the natural log of m to the 2/3 plus the natural log of n to the 1/3. And then finally, we can bring those exponents down and write this as 2/3 times the natural log of m plus 1/3 times the natural log of n. Next up, we're going to solve some equations. Same rules apply. If you have a logarithm equal to a logarithm, forget about the logarithms and just solve what's left. Let's move our x's to the same side by adding 2 x's and move the 27 over here by adding 27. Gives you 6x is 42, so x must be 7. You can go back and plug that in. And remember, you cannot take the log of a negative or 0, so it does check out. Sometimes you have to use your rules of rules of logarithms to move this stuff around. You now have the natural log of k squared equals natural log of 2k plus 15. So now you can forget about the natural log and just simply say k squared is equal to 2k plus 15. So really it doesn't really affect the fact that it's a natural log versus a regular common log or log with a different base because you're doing the same thing. 2 sets of parentheses. K here, adds, multiplies is a -5 and a +3. Now we are going to definitely have to check these answers just to make sure both are legit. When you go back up here and you plug in, you can't take the K of a negative or the natural log of a negative, so we throw out -3. When you put in the 5, gives you 2 times natural log of 5 equals the natural log of 25, and that is going to check out. Number 15, combine your natural logs first. We have the natural log of 72 minus natural log of 14 to combine two subtraction logs. You simply divide them. So that'd be 72 over 4, not 14. 72 divided by 4 is actually 18. So we have the natural log of 18 equals, then you have the sum of two natural logs, and we find the sum by multiplying them. So that'd be the natural log of 6a minus 12. And again, now that I have a natural log equals to a natural log, I can get rid of those and simply solve what's left. Move the 12 by adding. That'd be 30 equals 6a, so a would have to be 5. Always check it. Can I plug in 5 here, and you'd get 5 minus 2, which is natural log of 3, so that would be perfectly fine. Next up, anytime you have, again, a number out front, it can be moved up to an exponent. Then you have a natural log equals a natural log. So you can just drop those. Gives you m plus 4 squared equals 4. Since you have something squared, one method here, we could FOIL that out, but it'd be pointless because this is set up perfectly to just get rid of a square by doing plus and minus the square root of 4. Square root of 4 would be 2. Move the 4 over now by doing -4, and there's your two answers. M is equal to -4 plus 2. And m is equal to -4 minus 2. So here's our two answers. Again, let's always check and see if they work. Remember that you cannot take the natural log of a negative. If you were to plug in -6, -6 plus 4 is a -2. That would not work. However, plugging in -2, -2 plus 4 is a +2, so this one will. Number 17. This one, you have a log equal to a number, so on these you isolate the logarithm and then you simply rewrite it. This is a base of e, so you're going to rewrite this as e to the second power equals 8x. You could write e to the second power as an exponent, or you can just go ahead and divide by 8. So x is going to be e squared divided by 8, or in decimal form, that's about 0.9236. So there's your F value for x. Number 18. Let's combine the logarithms. You have a log minus a log. That can be combined with division. That'd be the natural log of x over 9. Next up, we're going to change forms. The base here is e, so we're going to do e to the 7th is equal to x over 9. And you can change it to a decimal here, or I like to just wait till the end. Go ahead and get rid of the division by 9 by multiplying, and x will equal 9e to the 7th, which is going to be approximately 9,869.6984 is your value for x. Number 19. e to the x power. Now, if you have e to the x, now again, isolate your exponential. We're going to change forms. This would be log base e of 57 is equal to x. However, we don't want to ever leave it as log base e. We're going to write it as natural log of 57 is equal to x. Now, if you look at your calculator, you do not have to use your change of base formula on these. Log base e, or this natural log of stuff, is a button on your calculator. So for these problems, all you have to do is the ln, or the natural log of 57, and that's about 4.0431 is your value for x. Let me try that again. Number 20. Step number 1, we always isolate our exponential by moving 6 here. That'd be e to the y plus 3 is equal to 30. We now change forms. We've isolated it. This is going to be the log base e of 30 is equal to y plus 3. Or instead of log base e, we can write that as the natural log of 30 is equal to y plus 3. And again, we can type this straight in our calculator, the natural log of 30. And that's going to be 3.4012 is equal to y plus 3. Last step, to move the plus 3, we're going to subtract, and that will give you 0.4012 is equal to y. Number 21. Step number 1, again, isolate your exponential. Get rid of 5 by dividing. That's e to the 4n power is equal to 19. Change forms. Once it's isolated, this will be log base e of 19 is equal to 4n. And again, log base e can be written as just ln of 19 is equal to 4n. And from here, again, you could divide by 4 or whatever, or you can type this straight into your calculator. The natural log of 19 is about 2.9444 equals 4n. Last step, we're going to divide by 4, and we get n is approximately 0.7361. And the last one, number 22. Isolate your exponential. Let's subtract 3. So you have 2 to the e, or 2e to the c minus 9 power equals 84. Divide by 2 gives you e to the c minus 9 power is 42. We change forms, and you could actually, this would be log base e. If you want to go ahead and write ln of 42, it'll save yourself a step, is equal to c minus 9. The natural log of 42 is going to be about 3.7377 is equal to c minus 9. To get rid of the minus 9, we're going to add, and that would give you 12.7377 is equal to c.